Hello everybody and welcome to another exciting episode of The Dang Show. Here to my left is my man Ryan.
This week we will talk about momentum and impulse.
Hey Ryan, do you know anything about momentum and impulse?
Nah man, but fortunately we got two expert scientists who will tell us what momentum and impulse is.
That's right. Welcome the two scientists Keen and Joey and their lab assistant Tommy. Pretty good. How are you?
Good.
Pretty good. How are you? What's up, Tommy?
So hey guys, it was really good to see you again.
Well, we're glad to have you back.
Yeah, same here.
So I heard that you got pulled over because you were driving 89 in a 70 zone. Keen.
So now, speed racer?
Yeah, I was getting pressured because of a stupid SUV pressuring me. Then it made me panic and increased my speed.
So, let me guess. This has to do something about momentum, correct?
Absolutely, momentum has a lot to do with cars, especially its mass and how fast you're driving.
Speaking of cars, do you have any example of momentum in action?
Sure, we do, and my lab assistant Tommy will explain to you.
Since both vehicles have different momentum, the white car has more momentum because the car has more velocity and mass. The green vehicle has less momentum because it weighs less and the velocity is less than the car.
Okay, but what's in momentum anyway?
Momentum is the inertia in motion, or you can say it's the mass in motion.
What?
Okay guys, let me rephrase it. So momentum is a product of mass and velocity, or P equals mv for short. It is the measure of how difficult it is to stop a moving object, where m is the mass and v is the velocity.
So you mean that if a heavier car traveling at the same speed as the small car has more momentum?
Exactly. Well basically, if an object has more mass, the greater momentum it carries. How much stuff is moving, how fast stuff is moving determines the momentum.
Oh, I see. But anyway, what's the unit for momentum?
The SI unit for momentum is kilogram times meter per second, or kg times m per s. Momentum is a vector quantity, meaning that it has both magnitude and direction.
So in your case, how does momentum come into play?
Well, as you know, I was driving 89 miles per hour and the car weighs about 1,660 kilograms. So if you multiply those numbers, then you'll get the momentum.
Here, let me calculate for you guys.
Whoa man, that's
wow,
a lot, dude.
that's very crazy.
Bro.
It is. Even Miss Salamando told me to convert my speed from miles per hour to meters per second.
So, how many meters per second did you cover?
Around 39.
Wow.
Dude.
Watch out, we got
Crazy,
speed
man.
racing over here.
Pretty good.
Yeah.
Are there any other examples for momentum other than cars?
Yes, even our body has a momentum. We'll show you a few clips of how body has momentum. How fast you run multiplied by how much we weigh equals our momentum. And Tommy here will explain it to you guys again.
Even our body has momentum. For example, when we run, the body has momentum. The body had a mass of 59 kilograms and the body is moving at a constant rate of 9 meters per second. We know that the velocity does not change, which means the momentum is constant.
So depending on how hard you hit the body, it determines the momentum, right?
Yes, correct.
So to make you guys understand more, we will show you a video of how momentum involved in basketball.
When the darker basketball hits the lighter basketball head-on, an external force acts on the dark ball and the momentum increases. This was an example for an electric collision. When both balls hit, they roll back to the source, which is as known as a head-on collision.
You know, Keen, I heard something about the conservation of momentum. I just don't get it. Why is physics so complicated?
That is just physics, Brian. So, the law of conservation of momentum states that in the absence of an external force, the momentum of a system remains unchanged.
Oh, so isn't kind of related to Newton motion law?
Yeah, exactly. When momentum doesn't change, it is conserved.
Ah, I see. I'm getting it now, Keen.
Hey, what about me? You guys forgot about me and my explanation of impulse?
Why would we ever forget about you, Joey?
Alright, just tell us what Impluse is, man.
Alright, before I get started, impulse is some kind related to momentum.
I still don't get it.
Yeah, that's right, you guys heard it.
Impulse is change in momentum.
Is that really all you gotta say?
Please explain more, dude.
Okay guys, it's a product of the force acting on an object and the time during which it acts.
So you mean that the greater the force acting on an object, the greater velocity would change?
Exactly. The formula of impulse is force times time interval or impulse equal Ft for short.
Okay.
I think getting it now.
You know what, Joey? Maybe you should give some real life examples so these gentlemen can understand what we're talking about.
A simple example is that if you are pushing a person who is sitting on a rolling chair, and if you took 2 seconds to apply more force, then you are changing a person's and the rolling chair's momentum. Let's show a video to demonstrate this in real life. And as always, Tommy will explain it to you guys again.
There are two cases that impulse change momentum. The first one is increasing momentum. To increase the momentum of an object, apply the greatest force possible as long as possible. Number two is decreasing momentum. If the change of momentum occurs over the long time, the heating force is small. If a change in momentum occurs for a short time, then the heating force is large.
Ah, I see. I think I'm finally getting it.
Well, did you guys get it? Well, hopefully, yes.
Look, lads, I'm starting to get it too, man.
Thank you guys for the detailed explanation.
Well, no problem, man.
No problem.
So I think this concludes our show, man.
Well, that's it for our exciting show of The Dang Show. Hopefully you guys learned a lot about momentum and impulse. Thank you, King, Joey, and Tommy for the explanation.
Yeah, no problem, man.